do it anymore since it's not a grade, or what do you think?
I don't
You think
know.
that is
I
that
know it's not a grade, but I do know that people who were put in this need to take that next math class, and they won't be allowed to take that next math class until they pass this, unless they are allowed to redo their placement test. But I also think that, did you guys have to take a placement test to get in here, or were you
Yeah.
placed in here based on your transcripts?
I had to take a placement test.
I
I
didn't.
You didn't?
No.
Okay. All right.
I took it years ago. I've been taking classes on and off at N-Trip for many years because I went into other trades. Like I told you, I'm an LPN. I went to Bryan and Stratton for coding and billing. So I've been doing other things. So I took the placement many years ago, which is still good. But I find this class very difficult. You know, I have to put a lot of time into it.
Okay. And I'm guessing that probably part of that might be from the fact that it has been a while since you last sat for a math class.
Yes, that could be part of the problem.
Okay.
Plus the way I work, lack of sleep.
Okay. Well, again, if I'm ever going too fast for you, or if there's something, if you want me to try to explain something a different way, please ask, because I want you to get the most possible, each one of you individually to get the most possible that you can from this. So, but let's look at a problem set together. And then
I was just going to say before I forget that when you gave us those little tips, like you reminded me yesterday that, look at this way first, so I know which way to approach something. That's always helpful.
Do you want the grocery list of factoring again before we get started?
I did take notes from it, but I can't find it at the moment. So if you want to do it, but
okay. Let me turn my thing back into a mouse. Let me reopen this. So for factoring, the first thing that I always look for is a common factor. No matter what the directions are, look for a common factor. With the numbers, for a common factor, it's the largest that goes into each coefficient. For the variable part, it's a variable that's common to all terms. And we use the lowest exponent. After I get the common factor out, the next thing I do is count terms. If there are 4 terms, we use that factoring by grouping. And with that factoring by grouping, let's say I have x cubed minus 2x squared minus 4x plus 8. Factoring by grouping is when we split it up the middle and we find what's common to the front half. Everybody see they both have an x. The lowest exponent on x is 2. And so if I think of taking x cubed and divided by x squared, I get x. If I think of taking minus 2x squared and divided by x squared, I get minus 2. Then I look to see what's common in the back. And the numbers are both divisible by 4. You have to remember, because this one starts with a minus sign, I'll take out a negative 4. Negative 4x divided by negative 4 is x. 8 divided by negative 4 is negative 2. And when we're doing our factoring by grouping, we're hoping that that binomial that's left is the same. And so that leaves me with x minus 2 times x squared minus 4. And so that's the grouping part of it.
That
Oh.
GCF on the second one is -4, right? Okay, thank you.
So this one, the GCF is x squared. This one, the GCF is -4. I'm going to go back to this problem in a minute, because this is one of those ones where we're not done yet. But that's what 4 terms split it up the middle. Instead of 4 terms, let's say we have 2 terms. And if there are 2 terms, we're looking for the difference of squares, which means that each term is a perfect square. And we're subtracting them. And so, a couple examples of that. If I look at that first factor that I have, x minus 2, I'm going to say that it's prime, because I know it's subtraction, but they're not squares. That second factor, though, that x squared minus 4, I have a square at the beginning. X squared is obviously a square. I also have a square at the end. Is everybody all right with the idea that 4 is a perfect square? It would be 2 to the second. And so if I have the difference of 2 squares, that will factor into the sum and difference. Of the roots, which means for x squared, x, for 4, 2, 2, because it's a minus 4, one's a plus and one's a minus. And so one more example, if I have x squared plus 4, is everybody all right? This one would have been prime because it's addition, not subtraction.
Why is it prime? Because it's addition?
It doesn't factor. If it's addition, it will not factor. If you've got the sum of 2 squares, it is not factorable.
Okay.
There's no way you can come up with 2 binomials that would multiply to give you that binomial. But putting the pieces back together, I'm going to pinch down a little bit. what happens is if it says factor completely, you might factor more than once. And so where we started with the x cubed minus 2x squared minus 4x plus 8, and we got that to be x minus 2 times x squared minus 4, that idea that I can factor more, this is still factorable. So that gives me x minus 2 times that was x plus 2, x minus 2. And so that would be factored completely. I've gone down as far as I can with each of them. But if you have 4 terms, it's real cut and dry, split it up the middle. If you have 2 terms, it's real cut and dry. See if there's something in common. After you take out the common factor, you're only going to be able to factor it if you've got the difference of squares. Where it's a lot more challenging is if we have 3 terms. And if we have 3 terms, there's 2 different types of problems that you see. If you have a leading coefficient of 1, it would be like x squared plus some number b, x plus some number c. You're looking for factors of c that add to b. Paying attention to your signs. So for example, if I have something like x squared minus 2x minus 35, because it's 1x squared, I know I'm going to start with x times x. And then I'm going to look at that negative 35 and look for numbers that multiply to negative 35 that add to negative 2. So 35 is 1 times 35. That'll never give me 2. And then it's 5 times 7. To be negative, if I think of positive 5 and negative 7, that does add to my negative 2. And so that factors into x plus 5, x minus 7.
Professor,
Yeah.
it's Diana. I kind of got in late because I got out of work a little late, so I'm sorry about that. I got another question. Like, I know it's off topic, but I was trying to do homework 19 last night, and I was kind of having trouble with that. Like, I didn't understand it. Like, I know that's way off topic, but I just wanted to.
It's not way off topic at all. Diana, what we're going to do today, because today is just basically a review class for you guys, and I didn't really have a clear-cut agenda of what I wanted to do today. So what the class had decided before you came in was we were going to go over a problem set together, a practice test together again, and then I'm going to stop, and everybody is going to do whatever they need to do to work in my labs and have Zoom open. I'm going to sit here in front of Zoom, and when people have questions, either on the problem set or anything else, we'll go over those. So
Okay.
go over the problem set. Are you all right? Because that was kind of the plan before you came in. During that practice time, I will work with you on every one of those questions that you're wondering about.
Okay.
Does that sound like an okay plan?
Yeah.
Okay. Thank you for letting me know.
Mhm.
Okay. And then if the leading coefficient is not 1, That was the ax squared plus bx plus c. I think everybody in this class preferred the AC method. Where we found factors of the product A times C that add to B. And then we used grouping. And I have to apologize at this stage of the game. I am not going to make one of those up. I'm searching for a book to get an example of one of those that we can do together. And then we'll let's say we have uh 12x squared plus 46xy minus 8y squared. Whenever I factor, the first thing I look for is something in common. And does it jump up and bite anybody on the nose that at the bare minimum, we have all even numbers? Since they're all even numbers, there's a common factor of 2, leaving me with 6x squared plus 23xy minus 4y squared. And so if I'm using that AC method, A is the leading coefficient, C is the constant term, the final term, the last one, -4. So that gives me -24. And so I want to find factors of -24 that add 2 in the middle, 23. -24, well, 24 is 1 times 24 with different signs. Does everybody see that if I had a -1 and a positive 24, that would give me my 23?
Yep.
So I'm going to change this into, can't lose my 2, 6x squared, and instead of 23xy, I'm going to have minus 1xy plus 24xy minus 4y squared. So I'm replacing that 23 with minus 1 plus 24. Now that I've got 4 terms, I'll split it up the middle. Not going to lose my 2. The first 2 terms have x in common, and I'll have 6x minus y. The last 2 terms have, 4y in common? When I divide that out, I'll have 6x minus y. Again, I can't lose that 2. Over here, I know I did my grouping right because I've got that 6x minus y in common. And when I think of getting rid of the 6x minus y, the other factor would be x plus 4y. And that was our AC method, combined with a little bit of something in common. And other than that, the only other hint I have for a trinomial is if it starts and ends with a perfect square, look and see. You might want to try perfect square, the square roots first. And that probably sounds a little ambiguous. And so let me look and pull out an example that would be like that. If I have 25, oh, I lost my example. P squared minus 70 PQ plus 49 Q squared. I'm looking at that, and the first thing that goes through my gut is, God, those are ugly numbers. But then I say to myself, wait a minute, isn't that 5p squared? And does everybody recognize 49 as 7 squared? And so that's what I mean by beginning and ending with a perfect square. So I'm going to try it. 5p and 5p, 7q and 7q. And then I'm going to look. Remember, if this one's plus, the signs are the same. They'll both be the minus sign. And now that one I'm really just guessing on. And so with all of them, it's really strongly suggested that you check with FOIL. And I've been lazy and I haven't been checking so far. I'm sorry. First, it would be 25p squared. Outer, let's see, 5 times minus 7 is minus 35. And then I'd have p times q. Inner, minus 7 times 5 is minus 35. And then I'd have p times q. If you wanted to, you could write that QP, but it's easier to recognize like terms if you put them in that alphabetical order. And then last, minus 7 times minus 7 is positive 49 Q squared. And if I look, minus 35 gives me that minus 70 PQ that I wanted in the middle. And so this would be my answer. And I might be forgetting something because this is just my grocery list of factoring off the top of my head with a few examples thrown in. But Lynn, is this what you were looking for?
Yes, yeah, I couldn't get my unmute.
Okay. Yeah. All right. So that's my just general approach when I factor. One, is there anything in common? If there is, take it out. You common factor first, the numbers are smaller and it makes your life easier. Second, count terms. 4 is grouping. 2 is the difference of squares. 3, we've got to factor that trinomial and we have to decide if it's got a leading coefficient of 1, it's the easier ones. If it's got another leading coefficient, use that AC method. Unless you notice you begin and end with squares. If you begin and end with squares, that perfect square trinomial happens an awful lot. And if you can recognize that, it's just, shorter. Okay. So, having done that babbling, Do you guys want to start by looking at that practice test?
Yes, that would be good. Thank you.
Lynette,
Yes.
you were the one who asked for this. And so I'm going to be a jerk and say, you said that you had more difficulties at the end. Do you want to start at the back and work our way to the front, or do you want to start at the front and work our way back?
No, start in the back. That would be good.
Okay. So I'm going to start with question number 20. Yes, and I actually clicked on number 20. Oh,
No, that one's okay.
okay. The square root of 25 is 5, and I'm hoping that's all right for everybody. I'm surprised that it showed up there.
Ooh.
Yes, them.
This should not have been in there.
Yes. You threw me a curveball.
No, that should not be in there. That should not be in there.
Yes, and that one.
That should not be in there. That's
Oh
what we're
my
doing
God.
next unit. That
And
should
that
not be in
one.
there.
Yes. That was a problem.
Okay. Well, I'll tell
Some
you
of
what
it.
we're going to do
Not that we
right
shouldn't know how
now.
to do them, but
What?
I don't remember. I said not that we probably shouldn't know how to do them, but
No, we didn't cover that yet. That's
Oh,
why I'm
good.
putting off to the next unit. I thought that those were in the next unit. Shoot.
Yeah, it cost me about, 5 or 6 points with that. 5 or
Okay.
6
Well,
questions.
what I'm going to do is I'm going to go through and I am going to give everybody credit for those 4 questions. So I'm going to just add those points to everybody's. Do you want me to create a different version of the problem set without those fraction questions in it for you to do from this point on? Or,
Yeah, that would be good.
Okay.
And could you reset it for me? Can you do that? Because I've already taken it twice and
I'll give you credit for those questions, and I'll also make a new version, and what I'll do is I'll keep whatever's the highest score when I look at averages.
okay. Now
Okay,
this one right here, I had a problem with. The sum of a number in a square is 12.
well, let's do that then. Okay, because this is a good one to start with. So what are we looking for?
hold on, I thought we could take the problem set as many times. Is it
You can.
unlimited? Oh,
No,
okay,
it's
thank
not
you.
limited. I
Okay.
think it's supposed to end on Saturday, but I will redo the problem set, chucking those last fraction questions, because those you have to do.
Okay, thanks.
Okay, so are you all right, Lynette? We're gonna let X equal the number we're looking for.
Okay.
If X is my number, what's its square? Would an X squared be the square?
Yes.
With me so far? And then what does the word sum tell me to do?
Addition.
So are you all right? The number plus its square is 12.
Okay.
So now they're out of order. Let me put them in descending order. X squared plus X equals 12. And then with these equations, remember if I've got an exponent, I always want to make that other side 0. So I'm going to minus 12 from both sides. Then I'm going to move this toolbar. Why are the toolbars always in my way? Gives me X squared minus X minus 12 equals 0. Is that doable so far?
Yes.
Then I'm going to rewrite that up here. There's 3 terms we have to factor. There's nothing in common, but it's one of those slightly easier factoring because it's only 1x squared. So X and X. I want numbers that multiply to -12 and add to -1. See, 12 is 1 and 12. I don't think I'll get a 1 from there. 12 is 2 and 6. I don't think that'll give me 1, yeah? How about 3 and 4, though? If I have a +3 and a -4, wouldn't that give me the -1 in the middle that I want?
Yes.
So this is going to be X plus 3, X minus 4 equals 0. And then if they multiply to 0, remember one of the two of them must be 0. So I'm going to make two smaller equations. X plus 3 equals 0. X minus 4 equals 0. And then to solve here, I'll subtract 3 from both sides. So one answer is -3. And over here, I'll add 4 to both sides. And my other answer is +4.
Okay.
Oh, Lord. I'm looking at this and I'm thinking this doesn't check. Does anybody see my careless mistake?
You're negative.
Yeah,
-X.
that should have been a positive X, shouldn't it
I
have?
was wondering about that.
And so this one should be the minus and this one should be the plus. Yell at me. And so the signs are different. So it should be +3 and -4, and then it would check. I apologize. Is that one all right now?
Yes, I actually did have it set up like that, but the
Mhm.
second time around, the number was like 210, and I couldn't figure that out. It was too high of a number. So I kind of understood that, but I ended up getting it wrong.
Well, with two, do they add to 12 or they probably added to something different?
It was the same question, but instead of 12, it was 210.
Okay, 210. I would just start. 1 goes into 210. Then 2 would be 105. 3 would be 70. And I just keep going down the list of numbers until I get something that, would give me the difference of 1. So I think 4, I don't think goes in there evenly. 5 would go in there 42 times. 6 would go in there 35 times. 7, 30 times. 8 won't. 9 won't. 10, 21 times. 11 won't. 12 won't. And I think the next one would be 15. And I think 15 goes in there 14 times.
Yeah,
And
that's it then.
That would do it. And yeah, sometimes when the numbers are big, it doesn't jump up and bite me on the nose either. And so that's why I start going through in order with my guesses. Does that help at all, hon?
Yes, thank you so much.
All right, you're welcome. So should we try the problem before this?
Yeah, you can. See what
Sure.
comes up.
All right, let's see. Oh, I gotta turn my finger back into a mouse. Whenever I forget to turn, and I'm using the pen instead of the mouse, and I say I've got to turn my finger back into the mouse. This is my level of maturity, folks. I always think of Cinderella. Never mind. Okay. You guys are more grown up than I, aren't you? Okay. Solve the equation. So what do we have here? We have x squared plus 8x plus 16 equals 0. Well, is anybody else breathing a sigh of relief because it's already in order and we've got 0 on one side? So we've got a factor. What would you folks try for factors of this one?
X plus,
They're both x plus, beautiful.
4.
Uh-huh. And does everybody see that 4 and 4 would give me 16 when I multiply? 4 and 4 would give me 8 when I add.
Could we apply that those are both squares?
Yep.
Okay.
And that was what I was gonna, if I didn't want to, I'm tired of me doing all the talking. I want to hear your voices. And so that was what I was hoping that somebody would notice, that 16 is a square. And so that would be, in my mind, the obvious first choice. Beautiful. Spot on. And so now setting each of those to 0. Do you see how both of them gives me -4? But they tell you only have to put it in once. You don't have to put in -4 as an answer twice. That one okay?
Yes.
Good. All right, I'm going to have you folks solve this one. And while you do that, I am going to take a minute off to the side on my Chromebook and see if I can create a better version of that problem set for you. Okay, how are you folks doing?
I'm doing fine.
Did I do okay?
Yes. That's what I got.
Good. All right. And so now, if that one's good, I'm going to clear it and look at the one ahead. Solve the equation. Oh, let's look at this one. X plus 4 times x minus 12 equals 5x. Is anybody else looking at this one and moaning? because I think we have to do a lot of work to simplify this one before we can try to solve it. What would you folks do first?
Put it in standard form.
Right? So should we multiply this out?
Yes.
Tell me what you get when you multiply that out.
X squared minus 8x minus 48 equals 5.
5x. Beautiful, 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 beautiful. Now, what should we do?
Subtract the 5.
Subtract the 5x, make one side 0. I like it. Oh. That line was not supposed to be there. Now we got to factor that, huh?
Yes.
It shouldn't be too terribly bad because we've got 1x squared. So it'll be x and x. But I'm looking at the 48 and the 13. Can anybody think of numbers that multiply to 48 with different signs that would give me 13? See, 1 and 48 doesn't do it. 2 and 24 doesn't do it. Does 3 go into 48? How many times?
16.
And different signs. Would 3 and 16 give me that magic 13?
Yes.
Yeah. Since it's a negative 13, we'll have plus 3 minus 16. And then setting each one equal to 0. I have to apologize. I started too low on the page. And so I'm not going to show all my work, but from here, can everybody get final answers of negative 3 and 16?
Yep.
Great. So we ready for another one?
Sure.
Oh, Lynette, I feel so bad that you were trying to do those fractions. I wish you would have sent me an email and I would have rectified it sooner and you wouldn't have had, oh, I hope you don't have as much gray hair as I do looking at that problem. Oh, I feel so bad, hon.
No, that's okay. Actually, I did it late last night.
Uh-huh.
So you would have been sleeping probably at that
Yeah.
hour.
I crashed early. As I was just looking at it, I think you were the only one that I saw with the score in there in the grade book. So I went through and I gave extra 5 points for it. But now there's a second problem set 4 in there, and you'll know which one to use because the name on it is problem set 4, do this one.
Okay, thank you.
Hopefully that one will be better for everybody. So this time we have to factor completely negative 81 r squared plus 1. And I don't know if any of these came up when we were looking at the other practice last time. But what makes this one ugly, cover its ears, I don't want anybody to hear me call any math ugly, is that it starts with a negative. And so what wasn't in my grocery list, Lynn, I'm sorry. If your leading term is ever negative, start by factoring out a -1. If you're starting with a negative number, you're always going to use -1 as that common factor. So that'll give me -1 times 81 r squared minus 1. And now that we've done that, does everybody see that two terms? With those two terms, does everybody see that there is a minus sign in the middle? So that's a good sign. And then with two terms, remember we said we want to ask, is that first one a perfect square? Is 81 r squared a perfect square?
Yep.
Good. And is 1 a perfect square? I
Yep.
think so. 1 times 1. And so we've got two terms, subtraction, perfect squares. So we'll have 9r, 9r, 1, 1, 1's a plus and 1's a minus. How's that one?
Not bad.
Okay. Diana, how are you doing with these? You're quiet. I can't hear you.
I'm doing fine with them so far.
Okay. And Diana, I'm sorry. Is she still here?
I don't see her.
No.
Oh,
Okay. Factor the following trinomial completely. X squared y squared minus 10xy plus 25. Step 1, anything in common? I'm thinking no. What about you guys?
No.
So 2, we've got a leading coefficient of 1. So it shouldn't be too bad. In order to get x squared, y squared, we'll start with xy. Now what jumps out at you with respect to that 25? Isn't that a square?
Yes.
And so being it's a square, does it make sense that I'll try 5 and 5 first? The signs have to be the same to give me a positive 25, and they'll both be minus signs. And when we multiply that out, are we going to get that minus 10xy in the middle? Yep.
Yes.
So I think we've got it.
Okay.
Can I clear it?
Yes. Thank you.
This one, the way they have it written, Does everybody see that I've got 4 terms? And so even if they didn't say so, because they have it with 4 terms, I'd try that grouping thing. In other words, I can't do 4 things at once. I'm not that good a multitasker, so let me look at 2 at a time. Do the front 2 have anything in common?
X.
Beautiful. When I factor out that X, I'm left with, think of dividing each of those by X. What would we be left with? Is everybody getting the X plus 7 there?
Yep.
And then in the back side, between 3 and 21, what would your common factor be?
Three.
Beautiful. And because that's a plus 3, we're going to leave that as positive. And when I divide 3x by 3, I get x. And when I divide 21 by 3, don't I get positive 7?
Yes.
And at this stage of the game, I always have a big shitty grin on my face. I'm smiling because when those guys match up, I know I did something right. One factor will be that x plus 7. And then if I picture crossing out the x plus 7, would my other factor be the x plus 3?
How come we have +3 in front of the x plus 7?
Because since this was a positive 3 to begin with, when I take out my common factor, it'll be positive. Instead, are you all right if I switch the problem around and do a hypothetical what if type of situation? Instead, if it would have been -3, minus 21, because that's negative, I would have started out by taking out, instead of a positive 3, a negative 3. Whoops. The sign on your common factor for the second half should have, almost always is the sign on that first term.
Okay, you know what I was doing is doing the 3x divided by 3 and canceling out those 3's and just making the term just plus x.
Well, we're going to have, which is what we're doing. That's where this x comes from, but we have to show what we're taking out. We have to show that common factor in front in order for grouping to work.
Oh, okay, so, okay, we still need to show that same common factor like we did on the front side, do the same,
Right.
okay.
And the
Okay,
reason we need that is because you see how those two, it's bothering me that I changed the sign, so I'm gonna change them back. You see how that plus x plus 3, I need that plus 3 in front to get my other factor.
right, yes, because it'll multiply out to get that, yep.
Mhm.
Yep.
Okay. That one okay with everybody? Can I clear it?
Yes.
Good, thank you. Factor the trinomial completely. 3x squared y squared plus 23xy plus 1. Anything in common? I'm thinking with that 1 at the end, we're not going to get a common factor. So would you guys, because this first is not a 1, would you guys use your AC method? 3 times 1 is 3. Is there any way that we can get numbers that multiply to 3 and add to 23? Is that possible? Can anybody think of any two numbers that would multiply to 3 that could possibly at all add to 23?
No.
No. And so guess what? It's telling us that this one is prime. Just doesn't work. If it's not possible, it's not possible. All right? Doesn't happen often, but every once in a while it does. Oh, this one's different. This time we've got 3x squared minus 30x plus 18. I'm going to shut up and ask you folks what you would do. Does anybody see anything in common?
Three.
Beautiful. And so let's start by taking that 3 out. And if it's in common, if I can factor that out, let's see, dividing this by 3 would be x squared. Dividing this by 3 would be minus 10x. Dividing this by 3 would be plus 6. And didn't we make that trinomial much easier to look at? Now we've got one of those trinomials with a leading coefficient of 1. So we're looking for factors of 6 that add to 10. See, factors of 6 could be 1 and 6, or it could be 2 and 3. Do any of those give me a 10 in the middle? The 1 plus 6 is 7, 2 plus 3 is 5. So I think the middle part is prime. The only factoring we're doing with this one is that common factor. And so we'll stop right there. Okie dokie.
And you stop there because neither of those two, the product of those does not equal the sum of negative 10.
Yeah, there's no way we could get that 10 from that 6.
Okay.
Okay?
Yep. Could we automatically figure that out just because 6 was already less than 10? Or not necessarily?
Not necessarily. Every once in a while you might get like, well, for example, 1 times 1 is 1, but 1 plus 1 is 2. So every once in a while, 1 times 2 is 2, plus 1 plus 2 is 3. So sometimes that middle term is larger. You kind of just have to look at the factors and see if it's possible to get that sum.
Right. Okay.
Oh dear. This next one is negative x plus 2x squared minus 3. What's wrong?
We have to get rid of the negative.
Even before that,
It's not in descending order.
it's not in order. So before, initially I looked at it and the first thing I saw was what you saw. Oh, it's starting with a negative. And then I looked at it and said, well, not really, because the x squared should be at the beginning and not in the middle. Now, would you folks do the AC method or would you do the trial and error? It's a matter of preference. Both would work. What would you do?
The AC.
AC? All right, so AC, 2 times 3 is 2 times, I apologize. I'm tripping over my tongue. I'm sorry. I apologize. 2 times -3 would give me -6. So we're looking for numbers that multiply to -6. That would give me a -1 in the middle. So that's 1 and 6. I don't think that gives me 1. How about 2 and 3? Can 2 and 3 give me a 1 in the middle? With different signs, if I have that +2 and that -3, it will. So that -1x, we're going to replace with plus 2x minus 3x. Now up the middle. The first two have 2x in common, leaving me with x plus 1. Over here, the second two, you see they both have a 3. And because the first one's negative, I'm going to take out -3. And if I divide that out, I'm also left with x plus 1.
And that's one thing I would do wrong. Sometimes there is the -3 divided by -3. I would just think that was 0, but it's really 1.
Right. And you know what? It's the way in which I was kind of taught to make sure when you divide something by itself, you get 1, is always in your mind, think that has to distribute back to what I had. So when I take my common factor out, I should always have the same number of terms on the inside so that it distributes back.
Okay.
And so common factor now is x plus 1. And the other factor would be that 2x minus 3. Good?
Yep.
What's in front of there? Factor completely. X to the 5th minus 2x to the 4th minus 35x to the 3rd. And the first thing I say to myself is, self, is there anything in common? Is there anything in common?
X squared.
I agree that there's x's in common, but I want to ask you, what's the smallest exponent on x?
Oh, x cubed.
Yeah, so let's take out the x cubed instead. All right, the more we can take out, the easier it'll get. So x to the 5 divided by x to the 3 would be x to the 2nd minus 2x to the 4th divided by x to the 3rd would be 2x to the 1st minus 35x to the 3rd divided by 35x to the 3rd is 35. So we've already said it's not prime, so ignore that one. Let's see what's left and see if we can go further. Because it's 1x squared, it's one of the ones that's not as challenging. We'll have x and x. And now we're looking for factors of -35. That would add to -2. Is it jumping up and biting anybody on the nose that the +5 and the -7 would do it? And because I'm so old and crotchety and have been doing so much factoring, probably I've been factoring longer than you guys have even been in existence. I haven't been taking the time to check by foiling because I've been doing it too long. But again, if this were a test, if I were you, I would check by foiling. First, x squared, outer minus 7x, inner plus 5x, last minus 35. And then when I see that I do get that negative 2 in the middle, then I'll know that I'm done. Okie dokie? And I apologize that we should have been doing a check on every single one of them. I'm sorry. Are you all comfortable with checking, especially your trinomial factoring by foiling? I'm not getting an answer. Can I assume that means it's okay?
Yep.
All right.
Yes.
Okay. Then let's clear this and try the next one. Oh, what fun. This is a cool one. Look at those numbers. 9x squared plus 54x minus 63. Wow. They're kind of big, aren't they? What would you do with numbers that big?
Find the greatest common factor.
I love you. Perfect answer. Yes. Is there anything in common?
9.
And when I divide by 9, I'm left with x squared plus 6x minus 7. And you see how taking out that common factor went from these huge numbers that make your head hurt to all of a sudden, that's a pretty easy one. With 7, we don't have too many choices, do we? What multiplies to 7? 1 and 7. To be a negative 7, the signs have to be different. And so if they're going to add to 6, does it make sense that it'll be minus 1 plus 7? We good?
Yep.
All right, great. Is this helping you folks? Are you feeling any better about these?
Yes, I am.
Good, and I apologize that those fractions were in there. I think what had happened was last fall, we ran out of time. And so tests 4 and 5 became one test, and the fractions got melded with the factoring. We were not running out of time this semester, so we're in good shape, and I apologize. I had forgotten that they had been put into the same test, that those fractions are where we're going next, okay?
Okay.
So don't worry. Right now, yes, they look unsurmountable because we haven't done them yet. But honestly, I'd say probably by the week after Thanksgiving, you're going to realize that they're very, very much like our factoring problems. And if you can factor, those will become easy once you know how. All right?
Okay.
So
No worries.
what's going on with this one? Is there anything in common all the way across the board to everybody?
No.
No. But what do you notice? How many terms are there? 1, 2, 3, 4. 4 terms I'm grouping. And isn't it easier to look at 2 at a time instead of all 4? How about the first 2? Do the first 2 have anything in common?
Five.
Anything else?
X.
Beautiful. And so when we divide by 5x, we're left with x minus 3y. How about the back two? Is there anything in common with those?
Six.
6. And what type of 6 should I take out? A positive or a negative?
Negative?
Beautiful, because the first 6 is negative. And when I divide that by negative 6, negative divided by negative, leave me with positive x. And then over here, positive 18 divided by negative 6 is going to give me that negative 3. And you realize if we would have taken off out a positive 6 instead of a negative 6, those terms wouldn't have matched. And so that would kind of tell me, oh, maybe I ought to try something different. But they do match. So I've got my x minus 3y, and I've got my 5x minus 6. And so I'm a happy camper. Can we clear it?
Yep.
This one, all they're asking you to do, it doesn't matter what it is just find the greatest common factor and take it out. And so I'm going to write it and be quiet and ask you folks to do that for me. Anybody get anything in common?
Six? Oh, 9.
9. Yeah, because this is 9 times 7, 9 times 9, 9 times 2, and 9 times 5. Did you guys ever notice that numbers that can be divided by 9, when I add the digits, it should add up to 9. 6 plus 3 is 9. 8 plus 1 is 9. 1 plus 8 is 9. 4 plus 5 is 9. And then when I divide out the 9, I get 7x 8, 9x to the 5th, 2x to the 2nd, and and 5. And as much as looking at those first 3 terms, I really want to try to take an x out. Does everybody see? Because the last one doesn't have an x, I can't. So I'm done. Or like my husband likes to say when I fall asleep on the sofa at the end of the day, put a fork in her, she's done. So we good?
Yeah.
And then one more. Greatest common factor. What would be common to both of those?
Nine. Or
9.
9y.
9y. Beautiful, 9y cubed. And that's your only answer for this one is 9y cubed. Beautiful, beautiful, beautiful. So I think we've done it. And except that I didn't type the answers in and hit submit, I think we've got 100 on this one, except for those 5 questions that I apologize for. Oh, Lynette, I feel so bad that you were stressing over those. Oh.
Yeah, I was up most of the night. So
Oh, hon, I'm so sorry. I owe you. I gave you extra credit on that assignment, so you've got full credit for those. And I'll do something else to make it up for you. I do feel so bad. Okay, that was, what I wanted to do, but I'm gonna do one more thing because I'm always gonna make myself a liar. I'm gonna share my screen again. And I'm gonna go over here. I'm gonna exit out of that. And then I'm gonna go over here. I don't want that one. I want this one. And so I want to refresh this. It's not gonna let me. So I'm gonna go back here to all assignments. And if you go in and you look at all assignments, folks, you're going to see that what I did was with problem set number 4, that problem set number 4, the evil one, it's not going to be available to you anymore because it's evil. And the problem set number 4, do this one, just work on that one. Okay.
Okay.
And what I did, if you did work on the evil one, you'll find that your score went up by 5 points, which is out of 20 questions, like 25%. So hopefully that makes a big difference for you. And so in the 20 minutes that we have left, I promised I would stop talking and you folks work on whatever you want to work on, but I'll sit here in front of Zoom and if a question comes up, I'll be here for you. Does that sound like an okay plan for the rest of the day?
Yep.
Okay.
Yes,
So
thank you.
if you need to go out
Yep.
and come back in, go for it. Otherwise, if you can just pull up your homework and work on it, that's fine. If you're comfortable and don't want to stay in class, I won't be offended if you leave, but realize that if you want some one-on-one help, that's what we'll do for the rest of the time. Okay.
All right,
So-
thank you.
Get to work.
All right. Talk to you later.
All right.